Okay, so calculating the heat of reaction from molar reaction enthalpy and the mass of a reactant. So here we have delta H for this reaction exactly as written, okay? So the first one is fairly straightforward, checking that we know what the sign convention is for delta H. If the sign is negative, that means the reaction is releasing energy, so that is what we've defined as an exothermic reaction. So we can see delta H is minus 55.3 kilojoules, so that is exothermic. That means it is releasing heat. If it had been a positive sign for delta H, that would be an endothermic reaction. That means our reaction is absorbing energy, okay? So we would have answered opposite. Okay, so positive delta H, endothermic, absorbing energy, negative delta H, exothermic, releasing energy. Okay, so then the next part of the question is asking us for the magnitude of how much heat is absorbed or released, okay? So what we have to do then is we have to look at the actual mass of nitrogen dioxide that is reacting, okay? So remember, this is for 2 moles of nitrogen dioxide reacting. So we need to work out how many moles there are in 55.8 moles of nitrogen dioxide. So we're going to use the molar mass as our conversion factor. And I calculated that the molar mass of nitrogen dioxide is 46.0052 grams for every 1 mole. That's going from nitrogen, which is like 14.07, and 2 times oxygen, which is 15.9994-ish, right? Okay, so then we're going to take that mass in grams that we actually have, 55.8, convert that equivalency for molar mass into a unit conversion factor. So we want our grams to cancel out, so they're going on the bottom, and we'll be left with units of moles of nitrogen dioxide. Okay, so where is my drawy thing? So grams cancel, give me moles of nitrogen dioxide. So 55.8 divided by 46.0052 gives me about 1.21 blah 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 moles. Moles of NO2. Okay, so that is important, okay, because our delta H for this reaction is minus 55.3 kilojoules per 2 moles of NO2 if we look at the balanced chemical equation. So delta H by reaction, I've got to take that minus 55.3 kilojoules, and if I want it in kilojoules per mole, I have to actually look at how many moles I have, and I have 1.21290637 moles of NO2. da, 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 da. And where's my calculator gone? I put that in the wrong spot. Hang on. So it's minus 55.3 kilojoules for every 2 moles of NO2 from the balanced equation. Okay, and we've worked out how many moles we actually do have. So I then have actually got, where did I write that down? I didn't mean to leave as much of a tail on this thing here, but I don't want to try and delete it. So then I'm going to, if I have my text, multiply it by the number of moles I calculated I do have, which is 1.21290637 moles of NO2. Hang on, give me a bigger box. So then my moles of NO2 should cancel out, giving me my total number of kilojoules of heat released in the reaction as written for the amount, which is 55.8 grams. So 55.3, I can't even read my own writing, divided by 2 times by 1.21290637, which is 33.5368, blah, 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 blah. And how many sig figs do we ask for? 3 sig figs, so 33.5 kilojoules, and that should have a minus sign on the front to tell me that it is being released. But the wording of this question, because it's already asked us if heat is released or absorbed, I don't think you need to put it into ALEKS with the minus sign. I think you just say the magnitude, the amount is 33.5, because you've already indicated that it's being released.